Let us state and prove Lagrange mean value theorem. Lagrange mean value theorem states if a function f is continuous on the closed interval a comma b and differentiable on the open interval a comma b, then there exists a constant c in the open interval a comma b such that f dash c equal to fb minus fa by b minus a. Proof of Lagrange mean value theorem is pretty simple if we know Rolle's theorem. So let's state Rolle's theorem. Rolle's theorem states if a function f is continuous on the closed interval and differentiable on the open interval and f of a is equal to f of b, that is value of the function at the end point are equal, then there exists a constant c in a comma b such that f dash c equal to 0. Let's look at the two theorem. Let's look at the two theorem. Both the theorem require function to be continuous on the closed interval. In case of Lagrange, function has to be continuous. In case of Rolle's theorem, function has to be continuous. So in both the case, we need function to be continuous. In case of Lagrange, we need the function to be continuous. In case of Rolle's theorem also, we need it to be continuous. In both the cases, we need the function to be differentiable. However, in case of Rolle's theorem, we must have it that f of a equal to f of b. So Rolle's theorem is a special case of Lagrange mean value theorem. However, in this case, we will prove Lagrange mean value theorem using Rolle's theorem. Let's do it. In order to do so, we will define a function g. Let g be a function continuous on the closed interval a comma b and differentiable on the open interval a comma b. So g is continuous as well as differentiable. So we want to apply Lagrange mean value theorem to g, or in other words, we want to show that Lagrange mean value theorem holds for g. But we will prove Lagrange mean value theorem using Rolle's theorem. So we define another function h. Let us define a function h on the closed interval a comma b by h of x equal to gx plus k times x, where k is a real number, k is a real number. We don't know what exactly is that real number. We'll choose it suitably. K is a real number. It is a fixed real number. We want to apply Rolle's theorem, so we choose k in such a way that we choose k in such a way that h of a turns out to be equal to h of b. That is g of a plus k times a is exactly equal to g of b plus k times b. That is, we take k to the left hand side and take common, k times a minus b equal to gb minus ga. That is, we take k equal to gb minus ga by a minus b. We take k equal to gb minus ga by a minus b. When we do so, it turns out that h of a is exactly equal to h of b. Now we see that h is continuous. First point, h is continuous on closed interval a comma b is g is continuous and k times x is continuous. So h is continuous, it is sum of continuous function. Second point, h is differentiable. H is differentiable. Why is it differentiable? Again, it is sum of differentiable function. Differentiable on the open interval a comma b. And for the third point, we have just seen that h of a equal to h of b. So we can apply Rolle's theorem to the function h. By Rolle's theorem, there exists a constant c in the open interval a comma b such that h dash c is exactly equal to 0. But what is h dash of x? But h of x is precisely equal to g of x plus k times x. We got k equal to gb minus ga by a minus b. So h dash of x, that's differentiation of hx, equal to d dx of gx plus d dx of k times x, that's just equal to k. So h dash of x equal to g dash of x plus k. So h dash of x equal to g dash of x plus k. So h dash of c equal to g dash of c plus k must be equal to 0. So there exists a constant c such that g dash of c plus k equal to 0. That is, g dash of c must be equal to minus k. And how much is k? K is equal to gb minus ga by a minus b. That is, g dash of c equal to minus of gb minus ga by a minus b. That is, g dash of c equal to gb minus ga divided by b minus a. And that c lie in the open interval a comma b, or c is greater than a, less than b. So we have proved Lagrange mean value theorem for the arbitrary function g. So we have proved Lagrange mean value theorem.